So now we're going to start doing some examples for ANOVA. Here's the website again. I put it in the last video, but I just wanted to make sure that everybody saw it. So if you can take this down, and if it doesn't work exactly, go to www.socialstatistics.com and then click on the test tab and then go to the first ANOVA test that you see, the one-way ANOVA without repeated measures. Okay, so let's do an example. Example 1. So a regional manager wants to know if there's a difference between the mean amount of time that customers wait in line in a drive-through window for 3 stores in her region. She samples the wait time at each store. Use an ANOVA test to determine if there's a difference between the mean wait times for the 3 stores at the 0.05 level of significance. Okay, so here's my data. I have my data for store 1, for store 2, and for store 3. When you take this data down, be careful not to scramble up the data. You don't want to mix them up because it's going to make your results wrong. So before I begin, I need to know my hypotheses. So for my null, the mean of store 1 equals the mean of store 2 equals the mean of store 3. Basically what I'm saying is the average wait time for store 1 is going to equal the average wait time of store 2 equals the average wait time of store 3. My alternative is that not all of the means for store 1, 2, and 3 are equal. Now I'm going to use the website to solve the problem. So here's just a copy. I just took a screenshot of it. As you see, I have treatment 1 is store 1, treatment 2 is store 2, and treatment 3 is store 3. And I put my data in the columns. You don't need to put any commas or anything. I would just put it just like this. So it'll make your life easier. There is a way to do it in the calculator. I think this is a lot easier, so you might want to do it this way. Okay. All right, I'm going to use a 0.05 level of significance, and you just click on that to use it. And this is what this gives me. So I have a lot of stuff. The cool thing is the first table gives me the means of each group. So for store 1, the mean wait time is 2.17, and the standard deviation is 0.55. For store 2, it's 2.4 with a standard deviation of 0.60, and for the third one, it's 0.82 with a standard deviation of 0.3723. Okay, so I looked at that, and all that did was give me the means and the standard deviations. Make sure you know where those are coming from because you might be asked for it on the test. Maybe not in the homework, but on the test, I might ask, what was the means for each of the samples? And look, it's right there. You don't even have to worry about doing it by hand. You can even go down here and see the totals, which this was the total of all 3 stores together, the average of that, and the standard deviation, basically the average standard deviation. So now down here, remember when I went through all of the talking about between the treatments and within the treatments, because the between means I'm comparing the samples and within means I'm comparing the sample to itself. Here's all that table, and they solved it for you, so I don't even need to worry about it. So the important things that it gives me is the F value and the P value. And if you see down here in red, it gives it to you. And it says the F value is 2.2949, and the P value is 0.12949. And it says here that the results are not significant. Before you do that, you got to understand what they're saying about the results are not significant. Okay, so I have all my stuff. Okay. All right, so my conclusion. I got my F test statistic, I got my p-value, and I have my level of significance. So I did 0.12949 is greater than 0.05, so I fail to reject the null, which means I'm keeping my null. So it means that the mean wait time for store 1 equals the mean wait time for store 2 equals the mean wait time for store 3. The correct way to conclude it is, at the 0.05 level of significance, there is not a difference between the mean amount times of wait for customers in the drive-thru. So that's basically what I'm saying. So what am I looking for? She wanted to know if there is a difference. So I'm concluding that there is not a difference. That's how you do the first example.